Hi, my name is Robert Patlavaney. I'm discussing international government midair collision safety regulations designed to increase collision risk compared to disobedient random altitude pilots violating regulations. This is a graphic that pilots use typically to help them remember how to fly the hemispherical cruising altitude rule. Pilots flying anything at all to the west are required to fly at even 1,000 feet. Pilots flying anything at all to the east are required to fly at odd 1,000 feet. Some of the details of the hemispherical cruising altitude rules are shown here, separating IFR, instrument flight rules, and visual flight rules traffic at different altitudes, but the same idea is basically applies to all that. For easterly and westerly flying pilots, they have to fly at cardinal altitudes according to this formula. That's a lot of wasted airspace in between those cardinal altitudes. I thought of a way to improve mid-air collision safety by diluting aircraft into the wasted airspace in between these cardinal altitudes. So I used a graphic like this to imagine for pilots how they would place a compass rose on their altimeter scale and fly in such a way that the 100-foot hand of the altimeter, which makes a full circle every 1,000 feet of altitude change, would have an angle on the compass rose that matches the angle of the heading of the aircraft actually flying across the Earth. When pilots fly in this way, aircraft headed head-on are offset automatically by 500 feet. Aircraft headed in a perpendicular closing would be offset automatically by 250 feet. Another alternative to the altimeter compass cruising altitude rule, or ACAR, is a formula preferred by NASA AIMS. Instead of having a repeating heading and altitude relation every 1,000 feet of altitude change, the NASA AIMS preferred version does something like it on a 2,000 foot pitch. Every 2,000 feet of altitude, the pattern repeats. And then, of course, there's random altitudes. Purely random altitudes don't require any kind of pilot aid. So I analyzed all four of these methods of testing aircraft collision safety in a 1,000 foot by 1,000 foot by 2,000 foot tall box with spheres representing aircraft flying at the various in the four various altitude cruising altitude regimes, and I found that aircraft at purely random altitudes were about 6 times safer than aircraft obeying the HCAR formula required by regulations around the world. And pilots obeying the other two linearized formulas based on the angle of the 100-foot hand of the altimeter were even safer than random altitude pilots. Russ Pielli of NASA Ames Research Center in 2000 published a corroborating result with his model based on 500 miles by 500 miles by 10,000 feet tall, and he found similar results enough that he had random altitude pilots being 5 times safer than HCAR pilots, and pilots flying the NASA preferred linearization of random altitudes as a function of random headings were 33 times safer than pilots obeying the hemispherical cruising altitude rules of international regulations. This is all pretty interesting, but I wanted to see what pilots thought about it, so I presented the results from NASA and my own modeling paper to over 600 pilots of the Experimental Aircraft Association in a 2018 webinar. Pilots got to vote, and only 11% of pilots preferred staying with the HCAR regulations. 89% of pilots preferred to fly at some kind of random altitudes because they were convinced, based on my webinar, that random altitudes are far safer than the HCAR altitudes of the regulations. 6 times as many pilots wanted to fly altimeter compass cruising altitude rule as the HCAR formula, and only 8% of pilots preferred to fly with the complicated pilot aid required to obey that linear formula every 2,000 feet of altitude change. And that's the results of my analysis and pilot feedback on the different possibilities for getting away from the dangerous international HCAR formula.